Hey guys, welcome back. This is part 2 of our lesson on imaginary numbers. So now we're going to talk about the powers of I. I acts like a regular number, and it can actually have an exponent and it behaves in certain ways. So let's first talk about what I is. I to the first power, we said, is the square root of -1. So if you have I to the first power, you just have an I, which means square root of -1. Now what does I squared mean? Well, that would mean you have the square root of -1, but you're squaring it. And we talked about in the last lesson that when you have squaring and square rooting, like we have here, those are opposites. They cancel each other out, and you're left with just your original number underneath the radical symbol, which is -1. So I squared equals a -1. I to the third power. Well, that's the same thing as saying I squared times another I. Well, let's translate that. We know I squared, which we saw in the example above, equals -1. And then we have just the letter I multiplied by it. So what's -1 times a positive I? Well, that would give me a negative I. Now let's try I to the fourth power. I to the fourth power is the same thing as just I to the second power again. Or 2 times 2, which is 4. Well, I to the second power, we saw up here, equals -1. So I would raise -1 to the second power. What's -1 times a -1? That would give me a positive 1. Let's try I to the fifth power. I to the fifth power means you take I to the fourth power and multiply it times another I to get I to the fifth. Well, I to the fourth we just saw is equal to 1, and then I is just an I. So positive 1 times a positive I gives you positive I, period. What about I to the 6? Well, I to the 6 can be written a couple of different ways. I'm going to go ahead and just say I to the 6 is the same thing as I to the fourth power times I to the second power. Because remember, 4 plus 2 in the exponents equals 6. Well, I to the fourth power, I found out already, is 1. And I squared, or second power, is -1. So 1 times -1 is -1. How about I to the 7th? I to the 7th is the same thing as I to the 4th times I to the third power. I to the 4th, we already know, is positive 1. And I to the third power, we know, is negative I. So positive 1 times negative I leaves you with negative I. Number 8. How to get I to the 8th power? Well, that's the same thing as saying I to the 4th power squared. Because 4 times 2 would give you that 8 that you want. I to the 4th power, we already know, is positive 1. And we're going to square that. Well, what's 1 squared? 1 times 1 is 1. So you're going to see some patterns. Every odd exponent, 1, 3, 5, and 7, has an answer of I with it. And you notice the 1 and the 5 are positives. Positive I. The 3 and the 7 are negative I's. If you had 9 and 11 there, they'd be positive, and it repeats again. Same thing with your even number exponents. I squared and I6 give you -1. I4 and I8 give you positive 1. So all your evens will give you a version of -1 or positive 1. All your odds will give you a version of positive I or negative I, basically. So now let's go ahead and move on and practice using some of these rules for number 13. Sorry about that distraction. There we had a brief announcement. Continuing on, let's find I to the 15th. So I can think of a couple of ways to do I to the 15th. And the way that I want to do it is I'm going to go ahead and do, let's see. Let's take I squared times 7, so that's 14, times another I. Well, we know I squared is a -1. We're going to raise that to the 7th power, and then multiply it times I. I to the negative, so I to -1 to the 7th power ends up being just a -1 times I. So -1 times I just gives me negative I. For number 14, I to the 62 power. Alright, so one way I can get that is I can say I to the second power times 31. Because 31 times 2, remember, is 62. So what is I squared? I squared is a -1. What's -1 to the 31st power? -1 times -1 times -1. I go back and forth. Since it's an odd amount of times, I'm going to end up back at -1. You can use your calculator to check it or do the math 31 times, but trust me, it ends up being -1. And now, we're going to use some properties of pure imaginary numbers. So now we have to simplify the expressions we're given below. And these act just like regular algebraic expressions. So for number 15, we have 4i times 7i. Let's treat these like FOIL. First, I'll do 4 times 7. That gives me a number of 28. Then I do I times I. I times I is I squared. Actually, let me write that a different way. I times I is I squared, so I'll put the 2 inside the little box. There we go. So 28 is just a number. What does I squared equal? If I go back up to my chart, I see that I squared equals a -1. So I squared is -1. Well, what's 28 times -1? -28. Better, simplify, easy enough. Number 16, let's multiply all our coefficients. -4 times +2 is -8. -8 times a -9 is a +72. Then I'm left with just I times I times I. So that means I have 72 times I to the third power. Well, if I go back up to my chart above, I can see that I to the third power is equal to -I. So what I really just have is, I'll take the negative sign and put it in the front, 72 with I attached to it. The negative sign traveled to the front in front of my coefficient. Number 17, I have 2i cubed. All right, so number 17, picking up, I have to go ahead and I have to do 2i to the third power first. That means 2, now using my rules of exponents, I'm going to have to do 2 to the third power and I to the third power. So 2 to the third power times I to the third power times 5i. 2 to the third power is 8. 2 times 2 times 2 is 8. Times the 5 I have over here in the beginning will give me a combined total of 40. So I know I have a 40. That takes care of this, takes care of that. Now I have I to the third power, that was right here. Then I have another I. So that really means I have I to the fourth power. So 40, and then I use my chart above. What is I to the fourth power? I to the fourth power is a +1. So 40 times +1 equals just 40. Moving on to number 18. So now I have number 18. It looks a little more difficult, but it really isn't. We're going to first square everything. So I squared times the square root of 3 squared times -8 squared times I squared. So looking at my chart, actually I'll handle the numbers first. I have 3 square rooted and then squared. When I square root and square a number, that cancels out. So I'm left with just a 3 down here on the bottom. I squared, according to my chart above, equals -1. And that's also again over here. -8 squared, however, means I'm going to take -8 times -8, which gives me a +64. So now I multiply all my numbers. -1 times -1 is a +1. 64 times 3 ends up being 192. So there is no letter I in my final answer here because the i's turn to -1s, which then turn to a +1, which then kind of just filtered out. Number 19, I have square root of -18 times the square root of -10. So I'll break these up. What I really have for -18 is the square root of -1, like we did in the beginning, times the square root of 18, times the square root of -1 again, times the square root of +10. I know the square root of -1 is I. Then I have another I over here. The square root of 18 and 10 now. I'm going to go ahead and multiply this 18 times this 10 to get the square root of 180 inside. So I have this happening now. Well, let me go ahead now and do some more simplifying. I have an I times another I. That means I really have this I squared. Then I have times the square root of 180. I need to break all that down. So the square root of 180 can be broken down into the square root of 36 times the square root of 5. The square root of 36, I know, will equal plus or minus 6. And I know the square root of 5 is just the square root of 5. That's just some random decimal. I'm going to handle the I squares. I squared, we said above, is equal to negative 1. So what we end up with then is the negative answer. So negative 1 times this 6 gives us a negative 6 times the square root of 5. That one was a little complicated. I'm going to assume that once I have this negative 1 here, that means I want the negative version of this number here. So that's why I wrote just negative 6 and not the plus to go with it. And I have the square root of 5 after it. And finally, number 20. So I need to break all this up. I know that I'm going to have a square root of negative 1 times a square root of 24 times the square root of negative 1 again times the square root of 3 times the square root of negative 1 again times the square root of 2. I have 3 square roots of negative 1. So I have the square root of negative 1 3 times. Or basically what I have is I to the third power. I to the third power equals negative I. So that's going to be my answer somewhere. Now I'm going to go ahead and take the 24 times the 3 times the 2 and figure out the square root of all those together, which is 144. This luckily is a perfect square. It is plus and minus 12. However, this negative I means I only want the negative answer. So my final answer, oops, not that, let me just erase that. Let me just properly erase it. So my answer is going to be the negative 12 times the I. And that's my final answer. I'm a little iffy about the last two. It's going to take me a little more practice to really get a good grasp, but here's the general idea of how you're going to work with imaginary numbers. Best of luck on this assignment, and please ask if you need any help or assistance.